name is Anthony Rabern, and I'm a fisheries biologist for the Georgia Department of Natural Resources. A few years ago, I was working near the dam on Lake Hartwell when I came across this site. Hundreds of dead fish floating on the surface of the lake. Of course, we know that dead fish are never a good sign. And I quickly realized that most of the dead fish that I was seeing were striped bass, ranging in size from, say, 4 or 5 pounds, all the way up to 25 pounds in weight. Something was happening down below the surface to kill these fish. And that's what I want to talk to you about in today's presentation. This is an aerial photograph of Hartwell Dam, and the area highlighted in yellow is where we found dead stripers on that day. As we motored across this area in our boat, we noticed on our depth finder a narrow band of fish, which we assumed to be striped bass. And they were tightly concentrated at a depth of around 120 feet below the surface. So we lowered the probe of our temperature and oxygen meter through the water column, and our measurements indicated that striped bass seemed to be squeezed into this narrow band of water that contained the only suitable water quality for their survival, it seemed, in the whole lake. The water that was above them was too warm for them to survive, and the water below them lacked sufficient oxygen. The entire striped bass population of Lake Hartwell just seemed to be trapped or squeezed into this narrow band of water. But over the next few weeks, conditions got worse, not better. Let me show you what I found. The blue wedge-shaped polygon roughly outlines the amount of suitable habitat below the surface where striped bass could live in Lake Hartwell at the end of August in 2018 when this die-off occurred. The water temperature in this bubble was in the 60-degree range, and the amount of oxygen was 2.4 parts per million. Now, that number may not mean anything to you, but keep in mind that striped bass prefer an oxygen concentration, say, above 5 parts per million. Suitable habitat started at Hartwell Dam and extended upstream, as you can see in the blue polygon, for about 2.5 miles. At its widest point, suitable habitat started 90 feet below the surface and extended down to about 140 feet deep below the surface of the water. I want you to watch what happened to this bubble, this suitable habitat, just 1 week later. The area in green shows how much suitable habitat was available just 1 week later. Notice that it shrunk by more than half, and the oxygen level was now 1.9 parts per million. Another week passed, and again the amount of suitable habitat was reduced by more than half, and the oxygen level was now 1.7 parts per million. Striped bass just can't survive with that limited amount of oxygen. But by mid-September and into late September, there was no more suitable habitat for striped bass. These findings confirmed our suspicions about what caused the striped bass die-off in Lake Hartwell. But not all striped bass in the lake died. So I realized there was more to this puzzle than we realized. Since striped bass stocking is an important part of our fisheries management plan for Lake Hartwell, we needed to learn more about how striped bass responded to late summer water quality conditions. And so we launched a study to evaluate their seasonal migration patterns, especially during the summer months, and to estimate how many striped bass may be dying because of the low water quality. The objectives of this project were to track seasonal migration patterns of striped bass in Lake Hartwell, to monitor their response to diminishing summer habitat, to identify if there were other summer refuge areas in the lake, and to estimate natural and fishing mortality. And finally, to use all of this information to assess our fisheries management alternatives. To answer these questions, we used electrofishing boats to collect a total of 59 striped bass from the lake. The length, the weight, the date of capture, and even the capture location were recorded for each individual fish. The striped bass that we collected ranged in size from about 6 pounds all the way up to 23 pounds, and they were caught from several different areas around the lake. For each fish, we made a small incision in the belly, inserted a very small ultrasonic transmitter into the gut cavity, then sewed up the incision, then released the fish near where it was captured. The whole process only took a couple of minutes, and all fish swam away in good condition. Each transmitter that was implanted into these fish emitted a unique signal, a signal that allowed us to detect and identify the movements of each fish. This signal would be an important part of tracking the movements of striped bass throughout Lake Hartwell. The device that I'm holding in my hand in this picture is a receiver. When a tagged fish was within about a half a mile or so of a receiver, the receiver recorded the identification number of the tag, the date, the time, as well as the body temperature of the fish. The red dots on the lake map show the location of where we placed our receivers. As you can see, there's a lot of empty space in between these red dots where the receivers were located. The mobile tracking unit pictured at the bottom left was also used to assess the movements of tagged fish in between these gaps where receivers could not pick up a signal. Mobile tracking proved to be an extremely important tool in this project that revealed some very surprising results. Before I tell you about the seasonal movements of striped bass, let me bring you up to speed on the numbers. After 30 months of tracking striped bass around Lake Hartwell, 36 of the 59 tagged fish were still alive. In percentages, nearly 6 out of 10 striped bass survived during our study. We also confirmed that 14 striped bass died. Of those 14 fish, 8 fish died from natural causes, and we know exactly where their carcasses are lying on the bottom of the lake. The remaining 6 fish died from angler harvest. We know that because their retags were reported to us by the anglers who caught those fish. That leaves us with 9 fish unaccounted for because we could not locate their signal after 9 months. So we considered those 9 fish that were missing, we considered them as dead. And we assumed that about half of them died from natural causes and the other half died from fishing mortality. So we assumed that 23 fish during the study period, which is about 4 out of every 10 fish, died from either a natural cause or by angler harvest. From a fisheries management perspective, those numbers are similar to other lakes such as Lake Lanier. With numbers like these, Lake Hartwell should be able to support a fishable population. The problem is that summer water quality is changing, and it seems to be getting worse. So how will that change in water quality impact the striped bass population? That's where this tracking data comes into play. This is a map of Lake Hartwell, and the blue dots pinpoint locations where we detected tagged striped bass. Overall, the tracking data showed that striped bass utilized pretty much the entire lake. In general, striped bass were in the tributaries during the winter months. Then they moved into the cove embayments during the springtime and toward the dam as summer progressed. By the fall, striped bass were able to roam all over the lake. But let's zero in on the summertime migration patterns. This slide illustrates the movements of fish 209, which is a 12-pound striper that was caught and tagged near Yonah Dam in February of 2019. You see the blue icon is where we collected that fish. And the fish that's being held in the picture, well, that's fish 209. I want you to watch this time-lapse video of the movements of this fish from May through September of that year. Keep in mind that water quality conditions in that summer were even worse than what I showed you in the water quality graph from the previous year. So if you're ready, let's watch the video. This slide illustrates the movements of fish 209, which is a 12-pound striper that was caught and tagged near Yonah Dam in February of 2019. You see the blue icon is where we collected that fish. And the fish that's being held in the picture, well, that's fish 209. I want you to watch this time-lapse video of the movements of this fish from May through September of that year. Keep in mind that water quality conditions in that summer were even worse than what I showed you in the water quality graph from the previous year. So if you're ready, let's watch the video. We pick it up in May, mid-May, and fish number 209 is left from Yonah Dam and is now in the main channel of the Tugelo River arm, just upstream of East Denali Creek, and it just seems to hang out in that general area for about a month or so. Then it quickly moves to the Seneca River arm and roams between, say, the mouth of Conross Creek, down below the I-85 bridge to the Broyles landing area. As we get into July, boom, it sprints down toward the dam because water quality has deteriorated so rapidly. This is the only suitable habitat for striped bass in the lake. It's right there in front of the dam. And it just hangs out there through the month of August in this bubble where it's being squeezed, if you remember the graph that we saw before. And if you've noticed that quick movement around the 1st of September, it leaves the area. It evacuates the lower lake. What you don't see in the video is that this fish actually returned to the place where we first caught it and tagged it, near Yonah Dam. For that fish, the area below Yonah Dam was kind of like its home territory, its home location. And what we found is that striped bass would return home in the late winter months, and then some fish, like fish 209, would return there during the summer months when they evacuated the lower lake. You know, fish number 209 was not the only fish to seek summer refuge in their home stream. In fact, mobile tracking allowed us to identify 3 tributaries that provided summer refuge for striped bass. The summer refuge used by fish 209 was the Tugelo River below Yonah Dam. We also found several fish using Conross Creek as a summer refuge, as well as 23 Mile Creek. We suspect that the Chaga River also provides summer refuge, but we were never able to confirm it. Because this was a multi-year study, we documented that the same fish returned to the same stream every summer and also used the same stream in late winter into early spring. You know, although having summer refuge like these streams is good, there is a downside to it. These tributaries are so small they cannot support large numbers of striped bass for several weeks in the late summer. So we still have a problem. What we discovered in this tracking project another survival strategy that I want to show you. Here's our lake map again. I want to show you a time-lapse video of fish 222, which was a 6-pound striper that was tagged and released in the Cone Ross Creek of March 2019. Picture in the bottom right is the South Carolina DNR crew that helped us in this project collect striped bass. This clip is going to show you the movements of this fish from June to November of 2019. So here we go. Picks up in mid-June, and it's in this Cone Ross Creek area, and then it moves quickly to this confluence between the two rivers. And then by late July, it's already down at the dam. We're in August, it's still at the dam. We're in September, it's still at the dam. And it stays there through October. And by November, we stop the video because this fish is moving back up the lake. So what's going on here? This fish stayed near the dam for the whole summer and never left, even when water quality conditions were at their worst. It raises a question: how did this fish survive? Well, the telemetry data gave us a clue. I want to use this water quality graph coupled with the telemetry data to illustrate another survival strategy that stripers use to cope with unsuitable habitat in late summer. The red line in this graph is the water temperature, and the blue line is the dissolved oxygen from the surface all the way down to the bottom of the lake. Based on the temperature data obtained from ultrasonic transmitters inside of fish 222, I know that it was hanging out around 125 feet deep on September 17th in 2021. At that depth, the water temperature was 60 degrees, but the amount of oxygen was nearly zero. But our transmitter data captured something amazing. For brief periods of time, this fish would swim up to a depth of about 50 feet, where the oxygen was much, much better at 6.8 parts per million. But because the water temperature was 81 degrees at that depth, this fish couldn't stay there for very long, maybe just an hour or so. And so it was forced to swim back down to the 60-degree water at 125 feet deep. Other researchers have observed this same up and down migration pattern, and they referred to it as porpoising. Fish that stayed in the lower lake during the whole summer would porpoise several times a day. This porpoising behavior is how some striped bass survived the anoxic conditions down deep. And this is a very different survival strategy than what we saw in the other fish that evacuated the lower end of the lake and moved into cooler upstream tributaries. Here's another way to look at the water quality conditions in Lake Hartwell. And I think it will give us a glimpse of the bigger picture and maybe also give us a glimpse into what the future holds for striped bass in Lake Hartwell. Remember, the driving force that triggers these two very different summertime survival strategies is the rapidly declining amount of dissolved oxygen in the deepest layer of the lake, where water temperatures are suitable for striped bass. When the dissolved oxygen level reaches, say, 2 parts per million in that deep layer, we call that layer the hypolimnion. I like calling it the death zone. And that's the critical time when striped bass must either leave the lower lake or porpoise up and down in the water column to survive. Well, I've been tracking the dissolved oxygen levels in Lake Hartwell for quite some time, so I want to show you some disturbing trends. This black line represents the average dissolved oxygen concentration in the hypolimnion, that deep layer in the lake where striped bass live during the summer months. And this is the average from 2010 to 2018. First, you'll notice that the line decreases, and that's natural. But also notice that by September, the black line never dips into the death zone. So all was good for striped bass and striped bass anglers during these years. But notice the dramatic change in 2019, 2020, and 2021. The dissolved oxygen concentration at the depth where striped bass lived during the summertime dropped into the death zone by around the first day of September. And you know what? Things aren't really getting any better in 2022 either. So a dramatic change has happened. Will it go back to normal? I don't know. But here are some of the conclusions that I've made from this project. First of all, we know that the hybrid bass population is doing well because they can handle the warmer summertime conditions. They just simply move up higher into the water column. The striped bass population, however, is not doing so well. Our annual sampling has detected a dramatic decrease in striped bass abundance, and summer water quality prevents fish from surviving for several years, long enough to reach a size of 10 pounds or greater. We also learned that cool water habitat in the lower lake forebay is insufficient by late August for striped bass to utilize continuously. And surface temperatures are just too warm for striped bass to tolerate for very long. In response to this late summer squeeze, striped bass either porpoise to the surface for brief periods, or they move to small tributary streams with cooler water temperatures. And finally, porpoising may not be a long-term option for surviving the summer squeeze. And summer refuge areas are just too small to support large numbers of striped bass. So we need to take some action. Because of the reduction in summer habitat for striped bass, we need to lower the striped bass stocking rate by half to 4 fish per acre. But we can maintain the hybrid bass stocking rate at its traditional level of 8 fish per acre. Hopefully we can reduce striped bass numbers to a level that the current habitat can support, which may allow some stripers the opportunity to live long enough and grow to a trophy size. But this change also means that Lake Hartwell will become more of a hybrid bass fishery. And the occasional striped bass that anglers will catch will just be an added bonus. The resource agencies should also do what we can to protect the watershed of summer refuge streams from activities that could raise water temperatures. In other words, protect stream buffers. And finally, we should consider stocking fingerlings in close proximity to known summer refuge areas. That may not be effective, but I believe it's worth a try. Well, that's my presentation. I hope you learned something about striped bass and how they cope with stressful summer conditions in Lake Hartwell. You know, overall, Georgia is blessed with an abundance of diverse fishery resources across the state. So I hope you'll take some time to go fish Georgia.